Hey everyone, and welcome back to the fourth part of our Python crash course. In this one, we're going to take a look at a few different topics, including Lambda functions, otherwise known as Lambda Expressions, the map and filter functions, as well as how to import modules, libraries, and packages into Python. Let's go ahead and move on over into our Jupyter notebook and get started. Start by discussing Lambda functions. Lambda functions, sometimes referred to as Lambda expressions, are small, anonymous functions that have no name. The key differentiating factor between Lambda functions and the regular functions that we looked at last time is that Lambda functions do not require a name and are generally much faster to write as opposed to the traditional functions. They are well suited for single-use functions, which you might use for any ad hoc data analysis tasks that you might need to perform. Let's have a look at how to create them now. For this example, let's create a function to sum two numbers together. To start with, we'll create this as a regular function, and then we'll transform it over into a Lambda function. As we did last time, we'll start with our def keyword, and then our function name, and for our parameters, we'll need two numbers, so I'll call these x and y. The code will then just return x plus y. And if we test this with 20 and 30, it provides the correct answer of 50. Okay, and let's now convert this regular function into a Lambda function. To create a Lambda function, we start with the Lambda keyword, as opposed to def with our regular functions. Then, we'll need to provide any parameters, which we had as x and y. So we'll put in x, y here. And then with our parameters defined, we can provide a colon, and this moves us onto the actual operation or code that we want to perform with our parameters. And this was simply just a sum, so we'll have x plus y. Unlike regular functions, where we then have to provide the return keyword, Lambda functions automatically return the value of the code after our colon, which again saves time when writing out your Lambda function. Something to note about Lambda functions is that they can only have single line expressions. So for more complicated functions, you will need to use a regular function with the define or def keyword. If we run this function, it'll return a Lambda function output. As our Lambda function has no name, to use it, we'll need to assign it to a variable. So I'll just create an add variable and then assign our function to this variable. If we then call add and provide two parameters, it'll give us our output below. Normally, you wouldn't use Lambda functions like this. You would use them in conjunction with other functions like map or filter, but we'll have a look at these in a moment. Before moving on to this, let's go through one more example of creating a Lambda function just to have a bit more practice. And this time, we'll create a function to square a number, so like we did in the last lecture. And just to consolidate what we did last time, we'll again create our function the regular way with the def keyword and then turn it into a Lambda function. So we have our define keyword followed by our function name, and then this time we just have a single parameter of x. And then we'll have the function return x to the power of 2. And if we check our result here with 5, it returns 25. To turn this into a Lambda function, we'll start by creating a variable to assign it to, which I'll just call square. We'll again need the Lambda keyword to initiate our Lambda function, and then our parameter, which I'll set as x. And then finally, our operation will just be x to the power of 2. We'll then just call square and pass in a number. Okay, so we now understand the syntax as well as how to create a Lambda function, but you might be wondering how they're actually any better than regular functions, and also what's the point of them, as here we still have to assign it to a variable. And the answer to this really is that they're best used with something called higher order functions. And really, we could have an entire lecture on higher order functions, but for now, the main takeaway of them is that they are functions that can take other functions in as their arguments. So basically, where before we might have passed in a value or variable into our function, this time we could actually pass in a function as well as a variable. In this lecture, we'll take a look at two of the more commonly used higher order functions, which are the map and filter functions. And let's start with map. In Python, map lets us apply a specific function to every element inside of an iterable. An iterable is just a sequence like a tuple or a list, for example. To demonstrate what map does, as well as how to use it, let's create a list of 10 numbers ranging from 1 to 10. Instead of writing these numbers out manually, let's instead use the range function that we've looked at before to create this automatically for us. I'll start by calling the range function, and then we wanted 10 numbers from 1 to 10. So we'll provide 1 as our first argument, which is the start value, and then our stop value will need to be 11, as range is not inclusive of the stop value. So if we specify 10 as our stop, we would only get numbers up to 9. If we run this, we'll get our 10 numbers, but we need them as a list, so we can just wrap this inside of the list function, which will then just convert this into a list, as we can see here. And with this done, I'll just assign our list to a variable called sequence. Okay, perfect. And with our list made, let's now use map to apply a function to each element inside of it. We could use a for loop for this, and then append the results to another list. However, map is a built-in function that allows us to skip out that initial step, and it's also much faster and more efficient computationally as well. Let's type in our map function, and then if we open up the Shift tab documentation menu, we can see its description along with its required arguments. We'll start by passing in the function that we want to apply, which for this example, we'll use our square number function that we created before. Then we need to pass in the sequence that we want to map this function to. If we run the cell, we'll now see that we have a map at this place in memory. If we want to view the results of our map function as a list, we can cast it by using the list function that we used before with range. And here we now have our list, but with our square number function mapped to every sequence inside of it. And this is a perfect example of where Lambda functions can come in very handy. Instead of having to define and use a full function, like we've done here, we can actually pass a Lambda function into our map function. And for one-off functions, such as this would be a much faster and better way of doing things. Let's now replace our square number function with a Lambda function that'll do the same job. So remove all of this, and then have Lambda, and then a parameter, which I'll call x, and then simply for our operation, we'll have x to the power of 2. And if we run the cell again, we'll get the exact same result, but this is a much cleaner way of writing code for small single line and single use functions such as this. But if you find Lambda functions confusing, then you can just use regular functions instead, and this is no problem. Let's now move on to the filter function. Like map, the filter function is a higher order function, so it's able to take in another function as one of its arguments. Unlike the map function, which allows us to map a function to an iterable, the filter function allows us to filter out specific elements. It also has a very similar syntax to the map function, so it'll be very easy to implement this function. For this example, we'll use the filter function to filter out any odd numbers from a list of data, so that we're left with only even numbers. We'll start by calling the filter function, and then we can pass in either a Lambda function or a regular function. In this case, I'll pass in a Lambda function, so I'll type in Lambda, our parameter of x, and then where that number mod2 is equal to 0. And this will return all numbers where that number divided by 2 has no remainder, which will be all of the even numbers. and then we'll apply this to the same sequence as before. Like last time, we'll need to convert our output to a list, so we'll go ahead and wrap this inside of our list function. And here we can see that we have our list of 1 to 10, but this time only with the even numbers present. So basically, this expression here of our number mod2 equals 0 returns a Boolean value, and then filter is only returning any values inside of our list where this value is true. Okay, and finally, we'll have a look at modules, packages, and libraries, and how to import them. This is something that we'll be doing a lot when we come to use other libraries like NumPy, Pandas, and more later on in the course. So I thought it would be good to introduce it to you now. To quickly summarize the differences between modules, packages, and libraries, a module is a bit of code, a package is a collection of modules, and then a library is related modules and packages put together. Inside of Python, there's a lot of code and packages that aren't loaded by default, and this is to save some memory and resources on our PC. For instance, there's a module called OS that provides us with some functions for interacting with the operating system. One of the commands inside this module is called getCwd, which stands for Get Current Working Directory, which gets and prints the current working directory. If we attempt to run this function, we'll get an error telling us that the name OS is not defined. And before we can run this command, we'll first need to import the OS module. To do this, we can use the import command, and all we'll need to say here is import OS, and that will then import the entire OS module. If we try our command again, it'll print the current working directory for our current notebook below. We could also import this with an alias. Sometimes the modules, packages, or libraries that you'll be importing will have very long names. So instead of having to write out the entire module name, we could instead use an alias. So OS is actually quite a bad example, as OS is obviously a very short name already. But if we go back to our import OS cell, and then at the end here, we'll just add in as O, this will mean that we can then access the getCwd function by typing O, a dot, and then accessing our function this way. For a module like OS, where it's a very short name already, it's not too helpful. But for some of the other modules we'll look at later on, aliasing can be a huge time saver. Okay, and that wraps up our main theory lectures for our Python crash course. We've covered a lot in these last 4 lectures here, so if you feel like you need to go back and rewatch any lectures before moving on, please feel free to go and do so. We'll be using a lot of these functions and code as we progress throughout the rest of the course. So if there's anything here that you haven't fully understood, then don't worry, you've got plenty more time to practice. If you've got any questions, as always, please feel free to post them down in the Q&A section below, and I'd be more than happy to help you out. In the next lecture of this section, we'll have a look at a few different practice questions and activities so that you can test and consolidate your learning from this section so far. So I'll see you in the next one.